Hi, this is a supplementary math lesson for advanced math, lesson 58B in your textbooks, wide and narrow parabolas. And I will be going through the example 58.4 on page 384 and 385 of your textbooks. If you want to turn to that now, go ahead and pause the video till you get there. Okay, so what are we wanting to do? They're going to give us an expression, and we recognize that it is a quadratic expression. The highest term of the unknown variable, x, is to the second power, okay? And we do have descending powers, okay? And we recognize any quadratic formula will plot as a parabola. And so they're wanting us to actually plot this expression, and they want the equation of the parabola. And from our previous lesson, lesson 54 on parabolas, we know the general expression for a parabola they want in this term, in this format here, okay, where x is our variable. This h term represents the location of symmetry for the parabola, and the k term represents the y coordinate of the vertex of the parabola. And so they say the drill that we go through to do that is we're going to perform a completing the square method to do that. So we arrange the equation in terms of y equals, I've just rearranged the equation that they've given us there, okay? And then we're going to go ahead and form our parentheses like we do with the completing the square method, and move that 17 off there. Now normally we sent that to the other side. We're going to keep it on this side because we want it in terms of y equals. So we're just going to move it outside of our parentheses. Okay, that keeps the first two terms. And I'm going to force in a third term for the completing the square method. But before I do that, I notice we don't have the x squared term with a 1 in front of it, and it has to be a positive one. So what we're going to do, we factor out that minus 2 attached to the x squared term. I'm going to factor out a minus 2, and that will leave me an x squared term with a 1 in front of it. Okay, I'm going to factor out a minus 2 for the second term. Okay, now notice that second term has a minus already, so when I factor it out, that's going to be a plus 6x, okay, minus 17, okay. So then I'm going to complete the square with this method inside the parentheses, okay. So what do I want? I want 1/2 of the middle term, which will be 6 divided by 2 is 3, a positive 3. And I'm going to square it. It'll become a positive 9. Okay, now this is a point I forgot to emphasize when we went through this in the original lesson. Okay, so when we do that, okay, we have added 9 to this side. Okay, we must add 9 to this side to maintain the equality. But we don't want that because we want it in the general form where y equals. We don't want any other numbers over here on this side. So instead of adding 9 to this side to maintain the equality, because I added 9 here, I'm going to subtract 9 on this side. Okay, subtract 9. But the twist with this lesson is, you notice, I am not actually adding 9 to this side. I am adding a 9 times a minus 2. So what am I doing? I'm actually subtracting an 18 because I factored out that minus 2. Okay, so when I would multiply this out, it would be minus 2 times 9, a minus 18. So I've actually subtracted 18 from this side. Okay, so to maintain the equality, I have to add 18 to this side. Okay, so that's a little tricky thing to keep aware of when you factor out that leading coefficient for the x squared term. Okay, you have to multiply our new third term, okay, by that factored amount to come up with the adjustment factor. Okay, so then our expression becomes minus 2. This now factors to square root of the first term plus the square root of the last term squared. That is the factor of this trinomial. And then I add or subtract my numbers as appropriate. I get a plus 1. Okay, and according to the top on page 286, or I'm sorry, 385, that is the expression of the parabola in proper format. And so what does that tell us? That tells us that our axis of symmetry along the x-axis is at -3 over here, -3. Okay, it tells us the vertex is at y equals 1, right here, y equals 1 along the axis of symmetry. It tells us, what does the sign out in front tells us? It tells us if it opens upward or downward. A minus tells us that it opens downward. So our parabola is kind of going to go like this. Okay, and then what does the 2 tell us? Well, the whole drill in this section, and you go ahead and read over it, when there's a number in front of the parentheses symbol, it's either going to be a widening of the parabola or a narrowing of the parabola. And if the number is an integer, that indicates a narrowing of the parabola. Okay, what we do, go ahead and put in a value for x. In this case, they used in the book x equals -2. So when x is -2, what does the value of 1? They put in -2 for here. They found that y equals -1 when x equals -2. They picked a point that was close to the vertex. Okay, so that point here ends up being -1 when x is -2. And we don't need to actually put in another point because we know, because this is the axis of symmetry, okay, we want 1 point to the right here, it want 1 point down. If we go take from the axis of symmetry, if we go 1 point to the left and go 1 point down, that maintains the symmetry of the parabola. So then our graph becomes this. Okay, for the parabola. And my arrowheads didn't show on the video here. Let me put those there just to show the graph of that parabola. So that is the drill. Okay, we use the rearrange the formula in descending order, perform a completing the square method to come up with the general form of the equation for a parabola. If need be, factor out the lead term of the coefficient for x squared. Okay, that also would include if x squared has just a minus sign in it. We want to go ahead and factor that out. Any minus or plus sign we want to put in front of the parentheses there in the general form. Okay, then go ahead and complete the square. Remember to adjust the number on this side. We don't send it to the other side like we did in completing the square method originally. We keep it on this side, okay, but the sign will be changed. And keep track of the fact that if we factored out the lead coefficient for x squared, we must multiply that into our new third term in the trinomial to come up with the proper adjustment here in our new expression. Okay, then we can get it in the general form. We only really need to pick one good point, kind of close to our vertex, not too close, or not so close that we can't figure out the exact shape of the parabola, but it helps here, this number in front of the parentheses will help us determine whether the parabola is wide or narrow. Again, if it's an integer, that narrows the parabola. Our parabola has a narrow shape there. If the integer is a fraction, or not an integer, if the number in front of the brackets is a fraction, it widens out the parabola. So go ahead and check that out on that lesson. So hope that helps. Shoot an email or a text message with any questions. And have a happy Easter, by the way. We'll see you in a week's time online here after your spring break. So long for now.